What's up, guys? We're going to look at atomic structure this video. Feel free to screenshot this page and make notes on it yourself. Now, this is a general atom. All of our atoms are going to be made up of nuclei containing protons and neutrons, and they're going to be surrounded by these electron shells containing electrons that orbit these nuclei. We'll learn in a few videos' time that this is an oversimplification, but for our purposes right now, that's absolutely perfect. Let's look at these subatomic particles in a bit more detail. So we have protons, we have neutrons, both of which are in the nucleus, and we also have electrons. Our protons, positively charged, P for positive, got a +1 charge. Neutrons, neutral, charge of 0, and electrons have a negative charge. And often, particularly when we come to structure and bonding and ionization energies, things like that, we'll often be talking about these positively charged nucleus because of the protons within them and our negative electrons that are orbiting that nucleus. And in terms of relative mass, we've got a mass of 1, 1, and 1 over 1,840. Now, all of our information about individual atoms is held here within our periodic table. And within our periodic table, we're going to look at fluorine in particular now. So what we will always have are these big numbers and these slightly smaller numbers here. Now, our big numbers are known as our mass number. The smaller numbers are our proton number. And here the clue's in the name, right? We've already spoken about the fact that the majority of our mass is from our protons and our neutrons. And that's where all of our mass comes from here. That's where all of our mass comes from. Our proton number tells us just that. It tells us our protons. And in an atom, the number of protons is going to be equal to the number of electrons. So let's note that down. So our mass number is equal to our protons plus our neutrons. And our proton number is our number of protons. And also electrons in an atom. And what I mean by that is obviously that's not going to be the case with ions, whereby electrons have either been lost or gained in order to create a charged particle. So let's break that down. So our mass number is 19. We can use that to work out the number of neutrons plus protons. And if this is the number of protons we have, we can work everything else out, right? So our protons for fluorine are going to equal our proton number, right? 9. Our neutrons is very simply going to be our mass number minus our number of protons. So we've got 19 minus 9 giving us 10. And our electrons, the only thing we need to check is there some sort of charge around here? There's not in this case. So that's the same as our number of protons, 9. And that's what we have here, right? We've got a nucleus containing 9 protons, 10 neutrons, and we've also got 9 electrons around the outside. It's worth us saying we've often got lots of these kinds of numbers, 10.8s. We're not going to use that mass number because this is the average mass of a sample of boron atoms. We'll look at isotopes shortly. So generally, when we're given a question, we're given an exact number of our mass. We're given this sort of thing that we have in this table here. So what we have here is our chemical symbol and our mass number. We need to then refer to our periodic table to work out what our proton number is, where we can work out everything else. So fluorine, 19, we've already seen, and we can look at our periodic table and see we've got a number of 9, a proton number of 9. So we've clearly got 9 protons. We've got no charge here. So clearly there are still 9 electrons. And in terms of neutrons, we've got our 19 minus 9 getting us to 10 neutrons. For our second question, we've got an isotope here. We've got fluorine 20. And an isotope is a different version of an atom containing the same number of protons, but a different number of neutrons. We'll look at this in more detail next time. So again, we've got our same proton number. By definition, our atom will always have the same number of protons. So if we've got a fluorine atom, it's going to have 9 protons. Electrons, again, there's no charge, so it's got to have the same amount. And for neutrons, I'm going to do my 20 minus 9, and I get to 11. Final example I'm going to do, and then it's your turn. We've got fluorine again. This time we've got a minus charge, but we've got fluorine 19 again. Now the number of protons, like I say, is never going to change. But we've got a minus charge. We've already looked and we've seen that our protons have this negative charge. And so if we've got a minus charge overall, it means an electron has been gained. So we have 10 electrons here. If it was a positive charge, we would have lost an electron, so we would have had 8. And in terms of neutrons, same maths again, our 19 minus our 9, and that gets us to 10. The rest are yours to give a go. Answers will be at the start of next video. Happy revising.